Hi, in this video, we will create dynamic structures using components. Now, most of the cases, almost 90% of the time in ABAP, you really don't need to create dynamic structures. You could just declare them statically at design time, and that should suffice your requirement. But in the 10% cases, you need a dynamic structure, and an example would be like if you want to transpose rows into columns. So now, first of all, to create a dynamic structure, we need a RTTI structure type variable. So let's define variables. So I need a struct type ref to cl abap struct descriptor. We also need a table type descriptor. So that one would be abap table descriptor. And third, we need a reference to data ref. So that would be data ref, again ref to data. So these are the three things we need as reference objects. Apart from these three, we need a component table, and we'll see later where we will use this component table. The component table, we can use it from struct descriptor. It's a constant, so static component table, not constant, it's a static. And then we need a structure for component table. We can define like, instead we can say like line of li comp. So we have object references, we have internal table, we have structure. Now the last thing we need is the memory pointer, and in SAP world the memory pointer is defined using field symbols. So first we need a memory pointer for a table, because ultimately in the end we will end up creating table. We can create a structure, but we could create a table also at the same time. It's just matter of a single line. And then structure. So now to define structure, struct. So for tables, we can define type standard table. That means any generic table. For structure, we have to define any. Let me see if I can reformat. Yeah, it's good. So now let's create a structure with two columns. So first of all, we have this component table here. So we need to create component table. Like, so let's say we can create ls comp, we'll say name. Let's take vbln as a name, and then ls comp. So we need a name, minimum, we need a name and a type. Now type we can derive from a type reference or the dynamic types. So that would be cl abap element descriptor. We can take element descriptor and then we can say get c. So this would define a character field of length 10. We do not really need to typecast, downcast, because it's the same type. And that's all. And then we can append this to our append ls comp to li comp. We can rather clear is absolute syntax. So ls comp will free that. And then we'll copy these two lines, or these 4 lines rather, down there, and then we'll change this vbln to, let's say, posnar. And since posnar is numc, I don't know what is numc type. Let's see, let's try to see what base type it is. Do we have any? Type n? Yeah, so type n, and we'll say it's a 6 character key. Format, save, and let's activate. Okay, so far we are good, no errors. Now we have our component table. So the next thing is we use these components to create a structure, and that we can create by calling our TTI type. So we'll say our LO struct, that's what we are creating, and then we'll get ABAP struct descriptor, and then we have a method on that create, and the input parameter is comp table. So basically this RTTI type refers to this component table, and it creates a reference based on these component types. So from that we can derive a table type. So we can say my table type CL ABAP table descriptor. We can again call create method, and in a create method we can pass our p underscore line type. So our line type is a reference of a structure which we just derived here on a previous line. So we have our structure, so let's label here create reference of structure and table. Now we have reference to structure, reference to table, and now we can create a data reference. So create data reference from RTTI object reference. So here we'll say create. This is similar to what we did in an earlier video. I will say my data reference type handle, and then we assign our handle. So here if I assign a table reference, then it will be a table structure. It will be a structure. If I assign a table reference, then it will be a table type. So we are assigning a table. That means we will have a table, and then we can assign this table, this data reference to our table reference, or table the table type which we defined as a pointer. So this gives us a table. Now let's say if I want to print, we can use CL demo output class, which has a method called display. Here we can input any input type, and this prints it really well formatted on output. So let me reformat, activate. So I'm here on my GUI and I will run that program. So 38, that's my program, F8. And here you can see now, so this is a table and we have two columns, a VBLN and Posner. Now this is a dynamic table, so which means we cannot really use any static declarations. If you want to append a row, you need to create a structure dynamically, and then so this is a data reference for, let me show you that too. So this is a data reference, data ref, let's define it as tab, and then here is a tab, and then we'll create another line. This is a data reference to struct. And we use this. This is tab reference. So to create a structure, we can do the same thing. We'll say use my struct type handle, and we define our struct type here, and then assign my data reference struct reference of that to field symbol structure. There's a typo, the struct should be ls, it's a structure and not a table. So let's correct here too. So now this gives us a structure there. And let me reformat, activate. So instead, if I say show my structure instead table, I would go there. I will put that, activate, and we go back and run. So now you can see it's a structure and it's not a table anymore. But how do we add values? How do I add a record? So that we have to do it dynamically as well, because we don't have a static access. So assign component, and then we define a component VBELN of structure. We have to define the structure here to a field symbol. So once you define something dynamically, then you have to continue with the dynamic declaration and dynamic use, because you cannot mix. You cannot go back to a static. It stays dynamic. So copy that. This is our posnar. And then we'll rename this as well, posnar. Now we are supposed to check here if the fields, let me put it that way. So if LB VBLN is assigned, just to prevent the dump, and we'll copy these two lines here down there, and instead of VBLN we use the posnar here. And then here we can assign a value. So if my VBLN is, let's say it's 00010 8000, is just a random number, as it has nothing to do with any specific posnar. It's a 6 characters, so 1 2 3 4 5 6. And now we are actually showing a structure. So I'm expecting a structure output. That's what we have here. Maybe we have too many numbers. There are 2 zeros after 8, so it's beyond 10 characters. So this is how it works for a structure. But let's say if I want to show it, let's say if I want to add structure to table. So let me do LFS structure to li table, activate, and then we go back. This will rerun. Oh, so we are still showing structure here, so we have to change that to table. What happened? Okay, there's an extra. Activate. Now we'll go back and run. So now we have a table, and we can actually increase. We can add many rows. So as an example, if I say copy that and add few more rows, since this is, we did not define any primary key, or it's not sorted table, so we can use the same row multiple times. So here you can see now we have 3 records instead 1 record earlier. So this is how you can create a dynamic structure and a dynamic table. Now, why do we use this, or where do we use this? So I'm going to show you that in the next video. Thank you.